Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you. I'm Philip Emeagwali. In 1989, I was in the news for providing the quote-unquote final proof that supercomputing across the world's slowest computers is not science fiction. Science deals with facts, while fiction deals with truths. Fastest computing across 64,000 human computers was first theorized as science fiction back on February 1, 1922. But for 7 decades, the idea of fastest computing in tandem and across thousands of computers was dismissed for the lack of evidence. In those years, the technology could not be harnessed and used to power the world's fastest computers. My contribution to computer science, that's the subject of school essays, is this. I experimentally confirmed the first world's fastest computing across the world's slowest processors. I discovered the quote-unquote final proof that the slowest processing across thousands of processors could yield the fastest computing. I made that supercomputing discovery 67 years later on July 4, 1989 in Los Alamos, New Mexico, USA. Solving the world's biggest problem across 1 million processors is to the world's fastest computer what playing games with only one processor is to the regular computer. Parallel processing takes computer science into a new epoch where millions of processors work together to power only one supercomputer. At 8:15 in the morning of July 4, 1989, in Los Alamos, New Mexico, USA, I became the first person to stand at the farthest frontier of the world's fastest computer. I was the first person to gaze out towards unknown territories that were not on the map of computer science. I gazed across an ensemble of the slowest processors to discover the world's fastest computing, which was then unknown to mathematicians and physicists who needed that new knowledge to solve their most difficult problems. That then unknown field of knowledge is where unexpected and unimagined new computer science, new physics, and new mathematics are almost guaranteed to be discovered. The world's fastest computing represents a remarkable confluence of new ideas, from the frontiers of mathematics to those of physics and computer science. My contribution to computer science is this. I was the first person to synthesize the new multidisciplinary ideas and do so with new ideas of my own. I synthesized ideas to discover that the world's fastest computing hid in the bowels of an ensemble of the world's slowest processors. It's not only the supercomputer that will benefit from my discovery of the fastest computing across the slowest processors. Our understanding of the supercomputer will increase over the coming years. I believe that the internet will evolve to become one coherent computer or a planet-sized supercomputer. 1 million years ago, our pre-human ancestors looked like apes. In 1 million years or a million, our post-human gods might ridicule our descendants as looking like humans. We might have only living silicon as our post-human gods that could achieve immortality. In the distant future, the aliens on Earth could be us, and the post-human gods on distant planets could be our descendants. I envision post-human gods of a million as thinking across a cosmic superbrain that is an artificial intelligence. That human-made genius would sprawl across an epic landscape to become their eighth continent. That powerful brain could enshroud our 7 land continents and enshroud the earth with their million electronic wires. I foresee our descendants being part humans and part thinking machines. The grandchildren of our grandchildren may not use their internet the way we use our internet. Their internet could be within them while our internet is around us. Post-human gods will not need supercomputers because there could be infinitely fast computing machineries. In 1989, it made the news headlines that I, Philip Emeagwali, had experimentally discovered how to solve some of the most compute-intensive problems in mathematics and physics. I was covered stories because I discovered how to solve the most difficult problems in mathematics and physics and solve them with the world's fastest computer that was powered by the world's slowest processors. Furthermore, I invented how to solve the hardest problems called extreme scale computational fluid dynamics. Likewise, I invented how to solve difficult problems across a new internet that's a new global network of up to 1 billion coupled processors. Each processor operated its operating system and shared nothing. I was in the news because I invented a new internet that's a new global network of millions or billions of processors. I invented how to parallel process or how to execute a billion set of computer instructions and how to execute them at once or how to execute them in parallel and across a billion processors. My invention of how the world's fastest computer can be built from the slowest processors enables the supercomputer to compute a billion times faster than the regular computer. I began my quest for that new internet in 1974 in Oregon, USA. I began as a janitor mathematician who put away the slide rule that was also called an analog computer that he bought in 1970 and brought from Onitsha, Nigeria. In late 1970, it seemed like I was the only person with a slide rule in Onitsha, Nigeria. I also put away my log table that was my only computing aid of 1967 at our home that was the nurses' quarters of General Hospital, Abo, Nigeria. I put away both my slide rule and log table to learn how to compute fastest and do so when solving compute-intensive systems of equations in algebra. In 1974, in Corvallis, Oregon, USA, I learned how to use the fastest computers to solve those equations arising in computational linear algebra that were impossible to solve on the blackboard or solve with pencil and paper. I learned how to solve a huge system of equations of modern algebra and solve them on a supercomputer that was powered by only one electronic brain. As a research mathematical physicist who came of age in the 1970s and 80s, I understood how those difficult mathematical problems arose from some laws of physics. I understood how the new calculus were derived and how those laws of physics were encoded into the system of partial differential equations beyond the frontier of calculus. They are called the 9 Philip Emeagwali equations. I made my debut as a computational mathematician on one of the world's fastest computers. I began supercomputing because I needed to solve a huge system of equations in algebra. I began my supercomputer quest on Thursday, June 20, 1974, in Monmouth, Oregon, in the Pacific Northwest region of the United States. I entered my programs into a time-shared supercomputer that was at 1800 Southwest Campus Way, Corvallis, Oregon. I submitted my executable programs that were written in high-level programming languages such as BASIC and Fortran, and entered them through my remote job entry terminal. BASIC is the acronym for Beginners All-Purpose Symbolic Instruction Code. It's a general-purpose high-level programming language. Fortran is the acronym for Formula Translation. It's the first choice programming language of engineers and mathematicians and other creators of scientific algorithms. My knowledge of supercomputers grew over the decade and a half that followed June 20, 1974. In the 1970s and 80s, and as a Black and African born in the USA, conducting a decade-and-a-half-long multidisciplinary research in computational physics, I was effectively banned from using supercomputers, so I couldn't conduct research on vector supercomputers that cost about $40 million each in the early 1980s. My accesses to these fastest vector supercomputers were revoked after they discovered that I was Black and African born. It was revoked at various institutions, such as the U.S. National Weather Service, Camp Springs, Maryland, and revoked from Ann Arbor, Michigan, for the Supercomputer Center in San Diego, California, that was operated by the U.S. National Science Foundation. In July 1985, I was tentatively offered a job as a supercomputer scientist at the Great Lakes Environmental Research Laboratories of the U.S. National Oceanic and Atmospheric Administration in Ann Arbor, Michigan. For practical purposes, I was offered the job via telephone when they presumed that I was white. 2 months later, on about September 24, 1985, I was flown into Ann Arbor, Michigan, to give my supercomputer hiring research lecture and do so in the lecture auditorium of the Great Lakes Environmental Research Laboratories in Ann Arbor, Michigan. When the decision makers knew that I was Black and African, they decided not to hire me as their supercomputer scientist. Fast forward 4.5 years after that rejection, newspapers in Ann Arbor, Michigan were writing stories about an African supercomputer genius named Philip Emeagwali. I was in the news because I had won the highest award for my contribution to supercomputing at the Great Lakes Environmental Research Laboratories. The white supremacists were shocked to learn that the black supercomputer scientist that they interviewed but rejected 4.5 years earlier is in the news for inventing the first supercomputing across the world's slowest computers. In 1989, I was in the news for the discovery of fastest computing. That was a scientific discovery that I was supposed to have made at the Great Lakes Environmental Research Laboratories. Because I was black and African, I wasn't permitted to make my supercomputing discovery in Ann Arbor, Michigan. As an aside, a search through the 8 billion videos that were posted on YouTube will reveal that nobody in Ann Arbor, Michigan, or anywhere else in the world, then and now, had or has the commanding grasp of mathematics, physics, and computer science that was needed to contribute the new knowledge that will enable the fastest computing across the slowest processors, as well as deliver lectures on their contributions to supercomputing that is on par with the 1,000 closed caption videos that I posted on my YouTube channel named Emeagwali. This gap in scientific knowledge was widely written about within Ann Arbor, Michigan, and beyond. Research scientists in Ann Arbor, Michigan, revered my discovery of the world's fastest computing. Their reference was documented in a special issue on Philip Emeagwali in their flagship publication called The Michigan Today. That February 1991 issue of The Michigan Today was titled "One of the World's Fastest Humans." The Michigan Today is a quarterly publication that's mailed to 610,000 university alumni. The PDF version of that February 1991 issue on Philip Emeagwali can be searched for and read online. As an aside, that Michigan Today issue on Philip Emeagwali was used to develop 2 nationwide law school admission tests. In September 2009, the LSAT, or Law School Admission Test of the USA, had a reading comprehension section that focused on Philip Emeagwali and that drew from that Michigan Today issue of February 1991. And in December 2009, the same American Law School admission test also focused on my contributions to computer science and drew from that Michigan Today issue of February 1991. That reading comprehension section of the American LSAT, as well as millions of school essays on Philip Emeagwali, put me on the same platform with Albert Einstein and William Shakespeare. Giving that level of recognition to a young black sub-Saharan African will always incur extreme jealousies from white supremacists who argue that Albert Einstein has a higher IQ than Philip Emeagwali. In Ann Arbor, Michigan of 1989, many white supremacists were sad and jealous for all the fame and attention that I was getting. The jealous ones among them had the shaky feeling that they could win that Nobel Prize of Supercomputing and do so if they had access to a supercomputer. They had access to supercomputers since 1946, but they lacked the scientific knowledge that I possessed and exhibited in my 1,000 podcasts and YouTube videos. So I was rejected on September 24, 1985 in Ann Arbor, Michigan, solely because I was black and sub-Saharan African, not because I lacked the intellect and knowledge. I was the first person to discover the world's fastest computing as it's known today. By the early 1980s, I was ahead in the supercomputer race for the fastest calculation in the world that could be executed across the slowest processors in the world. But as a black supercomputer scientist who worked alone, I was perceived as a threat instead of welcomed as a contributor to supercomputing. In the early to mid 1980s, I was blacklisted and denied access to vector supercomputers that were then the fastest in the world. I was forced to back off just before I could make a supercomputer breakthrough. In 1989, it made the news headlines that an African supercomputer genius who worked alone had won the highest award in supercomputing and won it for inventing how to solve a set of 65,536 difficult mathematical problems in large-scale computational fluid dynamics. At its compute-intensive core, each mathematical problem was a system of 366 equations of computational linear algebra. I solved each system on the slowest processor in the world. I totaled those problems across my ensemble of 65,536 processors. Each processor was coupled to its 16 nearest neighboring processors. Each processor shared nothing with its nearest neighboring processors. In the news articles, I was described as the African supercomputer inventor who invented how to solve those world record algebraic equations and solve them across a new internet that's a new global network of 65,536 off-the-shelf processors that were identical to each other. I was the internet scientist in the news in 1989. My scientific discovery of the fastest computing across a new internet that's outlined by up to 1 billion processors occurred on the 4th of July 1989. My invention was mentioned in the June 20, 1990 issue of the Wall Street Journal. That was my contribution to mathematics. That contribution has diverse everyday applications in science and engineering, such as weather forecasting. That scientific discovery was my eureka moment in invention as a new internet scientist. It was my eureka moment because I discovered 2 new internets. I theorized my first internet in 1974. My first internet was the supercomputer technology, which I constructively reduced to practice as my second internet that was comprised of my new global network of the 65,536 slowest processors in the world. I programmed them in 1989 to execute the fastest computations in the world and execute them while solving the most difficult problems that arise in mathematics and physics. My first internet was unknown in the computer textbooks that were published in 1974. That was the year I made my debut in supercomputing at 1800 Southwest Campus Way, Corvallis, Oregon, USA. My second internet was unknown in 1989, the year I recorded the fastest computer speed and recorded it in Los Alamos, New Mexico, USA. My invention of how to solve up to 1 billion difficult mathematical problems at once and solve them with a one problem to one processor correspondence and solve them across a new internet is the reason for writing school essays titled, quote unquote, The Contributions of Philip Emeagwali to the Development of the Computer. Because I wasn't allowed to conduct my scientific research and do so in conventional vector supercomputing, I was forced to change direction and conduct my research on how to harness the 65,536 slowest processors in the world and how to use those processors to invent a new supercomputer that is beyond super. The life lesson that I learned from those rejections was this: when one door closes, another door opens. When the door that led to the room that was housing the conventional vector supercomputer closed, the door that led to the building housing the most powerful supercomputer also opened. I'm a Nigerian-born large-scale computational fluid dynamics engineer who came of age in the USA and in the 1970s and 80s. My testbed supercomputing problems for my ensemble of 64 binary thousand processors range from global atmospheric flows to the fluid dynamics within an oil-producing field that's up to 7.7 miles or 12.4 kilometers deep, and that covers an area that's often the size of Mogadishu, Somalia. As a computational physicist, my supreme quest is to match physics models and simulations to the actual geophysical fluid dynamics being simulated. One of the most difficult mathematical problems is global climate modeling. It has an associated initial boundary value problem that's formulated at the crossroad where modern calculus, computational physics, and fastest computing intersect. That compute-intensive problem is mathematically defined over a physical domain. For my global climate models, I visualize the geometrical shape of the global warming problem as a globe that has a diameter of 7,900 miles. That globe was enshrouded by a concentric sphere that has an inner diameter of 7,900 miles and an outer diameter of 7,962 miles. The inner diameter of that globe was my geometrical metaphor for the surface of the earth. The outer diameter of that globe represents the limits of the atmosphere of the earth. My contributions to the invention of the first world's fastest computer, as it's known today, were these. At 8:15 in the morning of the 4th of July 1989, in Los Alamos, New Mexico, USA, I jumped in joy because I discovered the fastest computing across the slowest processors. I invented the technology as the new world's fastest computer that's defined across the slowest processors in the world. That new supercomputer that made the news headlines wasn't a computer by or in itself. I visualized my new supercomputer as my new internet in reality. That new internet was a new global network of off-the-shelf processors that were parallel processing as one seamless, coherent, and gigantic supercomputer and computing together to solve the world's most important and complex challenges. I first discovered the first world's fastest computing across my theorized internet. That's a new global network of 64 binary thousand or 2 raised to power 16 processors. My processors were identical and shared nothing. I visualized and theorized my 65,536 processors as identical computers that were evenly distributed around the earth. I visualized those 2 raised to power 16 identical computers as being equal distances apart and with much uniformity in processors and regularity in email wires. Over the 15 years that followed June 20, 1974, in Corvallis, Oregon, USA, my theorized internet evolved towards a new global network of 64 binary thousand processors that I visualized as encircling a ball in my 16-dimensional hyperspace. I called that ball a hyperball. Years later, that name, hyperball, was replaced by the current name, quote unquote, Emeagwali computer. I visualized the Emeagwali computer as shaped like a hypercube that's tightly circumscribed by a hyperball. The world's fastest computing resides at the crossroad where new calculus, the most large-scale computational physics, and the fastest computing intersect. Because fastest computing across a billion processors is a highly multidisciplinary field of study, it's problematic to explain where the mathematics ended and where the physics began and where the computer science continued. As a supercomputer scientist who came of age in the 1980s, I've been identified as a mathematician or a physicist or a computer scientist. In the 1970s and 80s, fastest computing across the slowest processors was very complicated and was mocked and ridiculed as science fiction and as a tremendous waste of everybody's time. In the 1980s, I was the only full-time programmer of the most massively parallel supercomputer ever built. That supercomputer was powered by 65,536 processors. Today, the world's fastest computer is programmed by up to 10,000 mathematicians and scientists. The reason I programmed such machinery alone back in the 1980s was that nobody else understood how to execute the fastest computing and do so across the slowest processors and record supercomputing speeds that's 1,000,000 times faster than a computer that's powered by only one processor. My contributions to computer science were these. I discovered how to harness millions of processors and use them to reduce the wall clock time to solution and reduce that time from 30,000 years within one processor to one day across a new internet, that's a new global network of 10.65 million off-the-shelf processors. My supercomputer invention occurred on July 4, 1989 in Los Alamos, New Mexico, USA. My invention of the first supercomputing across the world's slowest computers that outline an internet made the news headlines because it indicated progress in computer science and resulted in a fundamental change that changed the way we will look at the regular computers of tomorrow that could evolve from the fastest computers of today. The world's fastest computer speed that I discovered and that made the news headlines was this. The processing power of the world's fastest computer, which now occupies the space of a soccer field, can be increased to the power of a theorized supercomputer that could enshroud the Earth in forthcoming centuries. The world's fastest computer can weigh more than 1 million pounds or 8,000 Africans. The supercomputer of the future could be powered by trillions of processors that will be communicating as an internet that enshrouds the Earth. That planet-sized computer could enable discoveries across science and industry. In the 1980s, I couldn't conduct my research on how to harness 1 million processors and use them to solve the hardest problems in science, engineering, and medicine. As a supercomputer scientist, I came of age in the 1970s and 80s and in the USA. In those 2 decades, it was impossible for a black African-born but naturalized US citizen, such as myself, to gain the top secret clearance that was needed to work with the world's most powerful supercomputers. The fastest computers are used to simulate the explosions from detonating nuclear bombs. The US national laboratories, not universities and corporations, were the primary places that I could conduct my research in fastest computing across the slowest processors. In the 1980s, I had the visceral feelings that I was on a hot track to discover and invent how and why 1 million processors that computed in tandem could be harnessed to make future computers faster and supercomputers fastest. In retrospect, I was pursuing a supercomputer invention, namely parallel computing, that couldn't be invented under the vision of any US national laboratory or be invented as part of a supercomputing research team anywhere in academia. That plus the fact that I was black and African was the reason I wasn't hired as a research supercomputer scientist in the 1970s and 80s. In my unsuccessful hiring talks that I delivered in US government laboratories, I provided broad brushstrokes to research computational physicists and to research computational mathematicians. Back then, my theories on how to solve the hardest problems and solve them across 1 million processors were dismissed as science fiction. My idea was ridiculed as a beautiful theory that lacked an experimental confirmation. That beautiful theory was my new internet that I visualized as a new global network of 65,536 off-the-shelf processors that shared nothing, but we are in dialogue with each other. My broad brushstroke was to solve the most difficult problems in mathematics, science, and engineering. My supercomputing quest was to discover how to solve them across my ensemble of 2 raised to power 16 processors that were coupled to each other. In the 1970s and 80s, the world's fastest computer speed that I recorded on July 4, 1989 was mocked as a huge, embarrassing mistake and dismissed as science fiction. Achieving the fastest computing across the slowest processors was ridiculed as an empty pipe dream. In 1974 and in Corvallis, Oregon, I made a leap of my imagination. I leapt from a theorized global network of 64,000 human computers that were equal distances apart around the Earth to my theorized global network of 64 binary thousand computers that were also uniformly distributed around the Earth. I made that leap of my imagination because that's what humans do. Humans extrapolate from the known to the unknown. The genius is the ordinary person that found the extraordinary in the ordinary. The need for faster computers isn't going anywhere. The supercomputer will help define the political and economic powers of the 21st century. The nation that controls the technology that powers the world's fastest computer controls high-stake seismic imaging and petroleum reservoir simulation. Both technologies must be used to nail down the exact locations of crude oil and natural gas that were formed up to 541 million years ago. The nations that control petroleum technologies control the 65,000 oil fields in the world. This is the reason China wants to control the technology that powers the world's fastest computers. Doing so will enable China to take the first step in controlling some of the 159 producing oil fields in Nigeria. Therefore, it will not come as a surprise that the Saudi Arabian government placed armed guards around its most powerful supercomputer. One of the world's fastest computers is used to simulate the recovery of crude oil and natural gas from the vast oil fields of Saudi Arabia. Saudi Arabia classified the supercomputer simulations of their oil fields as state secrets. They are state secrets because the supercomputer is the key to the petroleum-dependent economy of Saudi Arabia. The supercomputer is the magical lock that, so to speak, opens the oil field that's buried up to 7.7 miles or 12.4 kilometers deep in the Sakhalin Island in Russia's Far East, and up to twice the size of the state of Anambra, Nigeria. The world's fastest computer is not only the pinnacle of the computer industry, but it's also big business. In recent years, the industry grossed $45 billion a year. I'm the only father of the internet that invented an internet. The first internet that I invented was a new global network of processors. I designed that internet to be congruent with the atmosphere of the Earth. I reasoned that the surface of the Earth is enshrouded by a 62-mile deep ocean of air, moisture, and water, such as the rivers, lakes, oceans, and even fluids like crude oil and natural gas. Furthermore, I visualized that 62-mile deep body of fluid as a concentric sphere with an inner diameter of 7,917.5 miles, or 12,742 kilometers. Not only that, I visualized that concentric sphere as tessellated into 65,536 equal-sized ocean of fluids that extended from the bottom of the oceans to the uppermost boundary of the Earth's atmosphere. I had to visualize the shape of my new internet as follows. My new internet must circumscribe a globe that has a diameter of 7,917.5 miles, or 12,742 kilometers. I defined my new internet as outlined as a new global network of 65,536 processors that has a one-to-one correspondence with 65,536 equal-sized physical domains. Each processor within my new internet will run one climate model. The world's fastest computer occupies the footprint of a football field and internally communicates across a total of 200 miles, or about 322 kilometers of cables, and it costs $1,250,000,000 each. That world's fastest computer is the top dog in mathematics. Where is the measurable paradigm shift or the step-changing discovery that's the greatest milestone in the history of the computer? Where is the continental drift of supercomputing? The increase in the speed of the supercomputer is the central essence of what defines progress in computing. The world's fastest computer could become the laptop computer of tomorrow. Speed is the essence of the computer. Therefore, a paradigm shift or a change in the way we think about the computer occurs when there's a quantum leap in supercomputer speeds. According to Moore's law, the speed of the computer is expected to double every 18 months. However, that factor of 2 increase in computer speed is merely evolutionary and conventional. That factor of 2 increase wasn't a paradigm shifting discovery. Visualization was the key instrument which I used to invent my new internet. That's a new global network of off-the-shelf processors which define and outline my new supercomputer. I used the cube as my metaphor for my new internet, and I visualized a processor as corresponding to a vertex of the cube and a bidirectional email wire as corresponding to each edge of the cube. Furthermore, I visualized my internet as a cube that was tightly circumscribed by a sphere. For my world's fastest computing emails that made the news headlines in 1989, I visualized my cube as a hypercube in the 16th dimension that was circumscribed by a hypersphere in the 16th dimension. I visualized my new internet as defined and outlined by a new global network of 16 times 2 raised to power 16 email wires, or a network of 1 binary million, or 1,048,576 bidirectional edges of that hypercube. I visualize my email wires as projected and as etched onto the 15-dimensional hypersurface of that 16-dimensional hypersphere that quote-unquote circumscribed it. Finally, I visualize those edges as my metaphors for my 1,048,576 bidirectional email pathways that emanated to and from my new global network of 65,536 off-the-shelf processors. That was my new internet. I visualized my processors as equal distances apart and as corresponding to the as many vertices of the hypercube on that hypersurface. For those contributions, I'm the only father of the internet that invented an internet. At 8:15 in the morning on July 4, 1989, in Los Alamos, New Mexico, USA, I discovered how to increase the speed of the fastest computer and do so by a factor of 65,536. I recorded my computer speed up across as many processors. On that day, I also discovered how to, in theory, increase that speed by a factor of 1 billion across 1 billion processors. I visualized those 1 billion processors as uniformly encircling a globe and doing so as a new internet. That new internet was where I executed the world's fastest computing. For 6 months after my discovery of fastest computing, leading supercomputer scientists were shocked at the speed of my calculations. But some supercomputer scientists mocked my discovery of the alternative way of executing the world's fastest computing, and using that new knowledge to solve the most difficult problems arising in mathematics. The naysayers wrote that Philip Emeagwali has made a quote-unquote terrible mistake. Those naysayers stopped laughing at me after it was announced that my discovery of the world's fastest computing has been validated. I won the highest award in supercomputing, and for the year 1989. My discovery of fastest computing made the news headlines around the world and became my signature invention. It's the reason Philip Emeagwali is the subject of school essays. Achieving that 65,536-fold increase in supercomputer speed was a fundamental change of tectonic proportions that changed the way we look at the world's fastest computer. Computing across up to 1 billion processors was a magical change because it was both unexpected and extraordinary. The reason my scientific discovery of the world's fastest computing made the news headlines was that the new technology was both unorthodox and revolutionary. In the conventional paradigm of supercomputing, called serial computing, the computer scientists visualized one processor as computing automatically to solve one of the most difficult problems in mathematics. One such problem was the initial boundary value problem arising at the frontier of calculus and large-scale computational physics. The system of partial differential equations that governs such initial boundary value problems is at the mathematical and computational core of the highest resolution global climate model that must be used to foresee otherwise unforeseeable long-term global warming. What separates the old and new ways of fastest computing is not the problem they solve, but how they solved it. In their old way, mathematical problems are solved within one processor. In my new way, they are solved across up to 1 billion coupled processors. Those processors emulate one seamless, coherent, and gigantic supercomputer. The internet is the precursor to a planet-sized computer that will shine like a beautiful star in a dark galaxy. Thank you. I'm Philip Emeagwali. Thank you very much. Thank you.
Insightful and brilliant lecture.